Hello everyone, today we will showcase how we test the ABB RER615 relay controller adapter ARCO, and we will show you all the protection function also with the control function. So let's see the connection at the beginning. So we have here the ARCO Control front panel. We have here the control area with the USB type A to be used with the Wi-Fi EDMX for wireless connection. We have also the USB type B for the PC connection to be used with the PC, and we have also two Ethernet port, power over Ethernet port to be used with the PC or with some other accessory like the CMGBS 588 in case if we need a BTB time source. And then we have the safe and the touch-proof test interface. As you can see, here is the extension cable which is 2 meter right now. You have optional to order it as a 2 meter or 7 meter. And here we have the power supply cable. We have the switch on and switch off button. Also here is the breaker control. You can use it from the front port to simulate the or to give close and open command for the circuit breaker. And you can see also the indication, as you can see, in green if the breaker is open and in red if the breaker is closed. Also you can make sure about the local HMI of the protection relay. So here is the connection. Here is the extension cable connected to the safe and touch proof, and then we have here the ROV2, which is our controller adapter. As you can see, it's about 30 centimeter or 40 centimeter. It's connected to the test plug of the protection relay. Here is the nameplate of the protection relay, RER615, and you can see from here the nameplate and the control circuit voltage is about 48 DC voltage, as you can see. Then here is the Ethernet connection to be connected with the PC for the BCM software to see the parameter setting. As you can see from here, we can, okay, so here is the BCM. Here is our software is connected to the RER615. You can see the current protection, for example. So here is the first stage of the earth fault, which is a definite time 50N, as you can see from here. And you can see also the parameter setting. The operation is on, and here is the first stage. The backup value is 0.02 in secondary. And here is a time multiplier. There is no time multiplier here, it's 0.05, but it's non-directional and definite time. So the operating time, as you can see from here, is 60 milliseconds. Okay, so here is the first stage also of the overcurrent. As you can see, the operation is on. The start value is 0.5 multiplied by IN. So we have the CT ratio is 600/1, so 0.5 means 300 ampere, and it's non-directional. Also the curve type is a definite time, as you can see, and the operate time delay is 40 milliseconds. Okay, we have also a second stage, which is a 50B. As you can see, it's on, and here is the number of start phases is 3 phases, and the setting group 1, as you can see. So the start value is 0.05 multiplied by IN, and it's IEC normal inverse. Okay, so from the relay HMI also you can get this value, okay, from the setting. So you can enter, then you go for the current protection. We will have here the earth fault PTOC, it's already off. Then we have the instantaneous stage of the overcurrent, as you can see, stage 2. So it's on, and 0.5 multiplied by IN, which means 300 ampere. Then it's non-directional, and the IEC definite time is the curve type, and the operate delay time is 40 milliseconds. Okay, then you can go for the second stage of the overcurrent, or the first stage of the overcurrent, which is the BDOC. You can see it's on, and the start value is 0.05 multiplied by IN, which means 30 amp, because we have a CT ratio 600/1. And then you can see the curve type, it's IEC normal inverse, and here is the time multiplier 0.05. Also for the earth fault, we have only one stage, which is 0.02 multiplied by IN, which means 12 ampere in primary, and it's non-directional. Time multiplier is 0.05, but it's already the curve type is IEC definite time with operation time delay equal to 60 milliseconds. Then you can go also for the setting of the control function, which is a recloser function. So you can see the operation is on, and here is the closing operation. Here is the manual close mode, and the wait time, and the maximum wait time is 10 seconds. The reclaim time is also 10 seconds. So here is the first reclose time, which is equal to 30,000 milliseconds, which means 30 seconds. Now you get all the parameter setting you need. Now let's start testing all these parameters using the ARCO Control software. Yeah. So here is the front view of the ARCO Control software. As you can see, the ARCO 400 automatically detects the type of the adapter, which is 24-pin ROV2. Then you can select whichever the control you need, like SCL or PICWIZ or ABB BCD. Since we have the RER615, we can select the other, and you can click apply. Here is the hardware configuration. You can specify the phase connection to be ABC or ACB as you like, or as per the network settings. And here is the nominal frequency is 50 Hz, and also you can specify the source and the load side VT. Since we don't have here a voltage connection, so we can select it as none. Then you can click apply. Here is the nominal voltage. Also, in case of you have a VT, you can specify this nominal voltage in line to line. And then we have the current. We have 3 phases of current up to 12.5 ampere per channel, and we have the CT ratio is 600/1, and the maximum for sure is 12.5 ampere. And if you put it by mistake more than this value, it will get back again to 12.5, because this is the maximum amplitude of the current channels. And then you can specify the city start point in case if you have a directional overcurrent or directional earth fault. You can specify city start point, is it earth towards the load or towards the bus bar. Then you can click apply. Also here you have to define the load or the pre-fault current to be used in some of the test modules, like direct, like sequence, to be used as a pre-fault current, just to make sure everything is resetted. And here is the bigger control, as you can see from the front panel. Also we have it here in the software. So simply also you can give an open command and close command, and you can check the indication from the front panel or from this contact, as you can see from here. Then you can define the report information, you can define the location, the model, the serial number, the company, and so on. Also you can enter any values you need, or any additional information you need to be printed out in your test result. As you can see from here, also additional information 3, you have a bigger box to enter whatever you need to be printed out in your test result. Here is the save button. You can select from 3 options to be saved on user request, so it will wait for you to click this floppy disk icon to save the test result. Or if you select always ask after each test, it will give you a pop-up message to ask you if you would like to save this test result in your test report. And also the autosave, which will automatically save everything, and you will not see now the floppy disk icon because it will be automatically saved. So let us get back again to the default option. Then you can click apply. Here is the setting. You can see the setting of the circuit breaker timing based on the manufacturer user manual for the trip time and the close time, also for the binary input and output, as you can see. And here is the binary input. You can see the first dot indicates for L1, second dot, if you have double dots, it will indicate to the L2 or phase B. Also the 3 dots, it will indicate for the L3 or phase C. Also you have here to specify the nominal range. As you can see from the nameplate of this controller box, it's 48 voltage DC. And here is the binary output, which indicates the 52A and 52B, which is the circuit breaker status indication, and also 69, which is the yellow handle status. Then you can click apply, and here you can specify the analog output check, just to make a wiring check, as you can see. So now I'm injecting 20 ampere in primary, and also you can select here the display option to be displayed in primary or in secondary values. Also the time can be displayed in seconds or in cycles. And now you can check the measurement from the relay itself. So IL1, IL2, IL3 is 19.8, 19.9, and 20. Also you can record it in a comment, or if you are connecting with the software, you can take a snapshot and you can add this image to be printed out in your test result. Now I will click off and I will save this one. I will give it a name like wiring check. Okay. Also you can specify IA and IP and IC. IA equal to 19.9 amp, IB equal to 19.9 amp, IC equal to 20 amp. Then you can append if you need to insert this to be a new test report or a new report, or you can overwrite if you have an old one which is wrong one, and you can override this one to the old one, so you will have the last saved ones. So now I will click append, then I will click finish. Now the second one is the pickup. We can select now the current pickup to check the pickup and the drop off for different fault loops. For example, if I am going to select or going to test the overcurrent, we can select the 3-phase or the phase-to-phase. For example, I will select now 3-phase ABC Also, you can enable the automatic ramp if you need to assess this test result automatically or manually with the button. But just because of some reclose doesn't have the start contact in the pin out configuration, so only you can see the LED of the relay in the front panel, and you can make manual backup. Then here you can define the step size as 0.5 ampere. Then you can go for the test. As you can see now, I will start the IO button to start injection, and here is the injection window, which indicates now or highlighted by red, as you can see. And here's the value right now. So I will increase it until reach to 30 amp, which is the backup of the first stage. You can see now from the relay. Now it's 25, 26, 26.5. You can see the measurement. Now it's 29, 29.5, and now it's 30. You can see now the backup as the start contact of the L1 and L2. You can select the manual backup signal. After you click this manual backup signal, you can see now the measured values of the backup value, which is 30 amp. Then you can save this value as well. You can give it a comment to be overcurrent RYP backup test. Then you can click append. Also, you can get back again from this navigation pane here, and you can select a different fault type to test the earth fault. Then you can go for the ramp configuration again, and you can start from now from 0, for example, because we are expecting 12. So now everything is resetted. You can see the relay itself. We are expecting 0.02, which equal to 12 ampere. Now it's 7, 7.5, 10.5, 11, 11.5. Now it's 12, which means the start of the earth fault. You can see from here also the backup value is 12 ampere. You can select to save it. You can change the name only to be earth fault R2N. Then you can append. Second one, also you can go for the trip time characteristic to check the trip time of different stage, for example the overcurrent stage or the earth fault stage. So we have the backup value of the earth fault is equal to 12 ampere with definite time, and the time the operating time is 60 millisecond. If you have second stage, you are free to enter it here as a backup and the trip time. If you don't, you can disable it, and then you can go for the pre-fault. It's recommended to be longer than the reset time, which is 10 seconds, so we can put it 11 seconds. Then we can go for the fault. We can select the A to N since we are going to test the earth fault protection. Then you can define the test shots now as 24 or 90 amp. You can put it like third one also like 120 amp, but all of them will be tripped with a 60 millisecond because it's a definite time. As you can see from the curve here, you can specify also the relative tolerance, absolute tolerance, and the ARCO control will take whichever is greater for automatic assessment of the test results. Then you can go for test. Then you can click start. Now it's in pre-fault stage. Then it will inject 24 amp with 60 millisecond. You can see now it's 24 millisecond, but it's passed based on the tolerance or the allowed error bands. Now it's in the pre-fault again, and the breaker is closed to simulate the second shot, and which is 70 millisecond. Now it's pre-fault again, and the circuit breaker is closed before the third and last shot. So now it's 68 millisecond. Now you can save this test result. You can give it a name like earth fault now trip time test. Then you can click append. You can get back again to change the setting to be overcurrent. Now we are expecting the backup to be at 30 ampere, and we have the curve is IEC normal inverse, and the time multiplier is 0.05. as you can see, and we have second stage, which is a definite time at 300 ampere, and the trip time is 40 millisecond. Then you can go for the pre-fault. Also the pre-fault time is 11 seconds again. Then you can go for the fault. Now you are free to select 3-phase fault or phase-to-phase fault loops, just to avoid interference with the earth fault protection. Also, the trip wait time should be longer than the maximum expected trip time, so 20 seconds is more than enough. Then we can select now the test shots. Since we are dealing with 30 amp, we can inject 60 amp for the first curve, and 90 amp, and 120 amp, and we can insert a new shot for the 600 to check this definite time stage. Then you can go for the test screen, you can click start. Okay, so 501. Now it's pre-fault and the circuit breaker closed again before the second shot at 90 amp, and the expected trip time based on the IEC normal inverse equation is 315 milliseconds. Now it's 310 millisecond and it's assessed as pass. If you see this green plus, means the test is automatically passed or automatically assessed as passed based on the tolerance. Here is the third one, 243, and here now this is a pre-fault stage before the last shot, which is a definite time shot, and the expected is 40 milliseconds at 600 amp, which is now 59 milliseconds. Then you can save this result as we did with the ARCO fault to be overcurrent RYP trip time test. Then you can append. Okay, so now we tested the second stage, the first and second stage, the two stages of the overcurrent protection in IEC normal inverse and definite time. Then you can click finish. The last one, we can now test the tripping sequence. Now you can select from different modes, the recloser or sectionalizer. If you select sectionalizer, it will be simulated. The ARCO 400 will simulate upstream recloser, because there is no circuit breaker in the sectionalizer. It's only a disconnector or a switch, no any arc quenching medium. And if you select the device under test here to be recloser, it will be simulated with the downstream recloser. Then you can go for the load. Here is a pre-fault to be more than or longer than the reset time or the reclaim time of the circuit breaker. So we have 10 seconds, now 11 seconds is more than enough. Then you can go for the fault. You can now define a different fault loops. I will select a ground fault, which is a phase A to N fault, and now the fault current you can specify it as you like. As a 600 ampere, here is a 3-phase trip or single phase trip, depends on the scheme of the recloser application. Then you can go for the configuration screen. Now you have 3 modes. You can select successful reclose or full sequence to lockout or coordination with the downstream recloser. Now we will test the successful reclose. So here is the shots to lockout to be 2, because we have only one shot. So the cycles to successful reclose will be 1. Here is the maximum dead time is 40 seconds, should be longer than the expected reclose time, which is the expected dead time we have in the parameter setting equal to 30 seconds. So 40 seconds is more than enough. Here is the maximum trip time to be 20 seconds, and also you have to enable here the verify open interval to measure the dead time, which is expected to be 30 seconds, and the tolerance 100 milliseconds. Then you can go for test. Then you can start your test. Now it's in the pre-fault state. Circuit breaker is closed. Then it will transfer to the first trip at 600 amp with 60 milliseconds as a definite time. What happened? So now is the dead time. We are expecting 30 seconds, as you can see from here. So now it's 25, 26. Also the autoreclosure in progress and LED is on. Now it's closed after 29.979, which means 21 millisecond error. And here is the load time, just to make sure everything is successful. Recloser. Okay, so we can save this test result. We can give it a name like successful recloser test. Closing test, and you can append. Also you can get back again to check a different mode. Now we will select the full sequence to lockout, which means it will give a second trip after the first reclose. We will also verify the open interval, which is the dead time of the first shot, and we can select okay. We can select apply. Here is the pre-fault to simulate the load condition. Now the first trip happened after 74 milliseconds by ARCO fault protection. Now it will count up to 30 seconds for the first shot of the reclosing. We will measure it here as you can see from this screen. Okay, so it's 27, 28, 29, now 30. So now it's closed. You can see now the second trip happened, which happened at 75 milliseconds. And now we need to wait until the 40-second elapses just to make sure that the circuit breaker is locked out and no any second reclose shots. Also, you can press here if the lockout is verified and you need to stop the test. You can click here. Otherwise, you can wait until the 40-second elapses and the automatic assessment of the lockout status of the circuit breaker. Okay, so now it's finished. We can save this test result, but instead of successful, we will rename it as unsuccessful reclosing test, and we can append. We can finish. Then to see the last saved test report, you can click this icon. It will direct you to the last one, which is 3-. You can see from here all the test, the time and the date stamp. Also the CT ratios, the BT ratios, the adapter used in our test scenarios. And here is a comment I have added, which for the IA, IP, IC for the wiring check, then the backup test for the overcurrent RYB test, and here is the value measured at 30 amp. Also the backup for the earth volt A to N backup at 12 amp. Then you can see here the trip time characteristic for the overcurrent RYB trip time test with the 3 shots we injected, and here is the expected trip time based on the curve equation, and here is the measured trip time, and here is the tolerance band from the minimum to the maximum, and if it's assessed pass or fail. This is automatic assessment. Also you can see the same also for the 8 volt. We have only one stage, different time. You can see it from here. And then we have the tripping sequence. We tested the successful recloser for the first shot. Here you can see the expected open interval time is 30 seconds. Okay, so and the measured is 29.985 seconds. Also you can see the unsuccessful reclose or the lockout reclose also. So we have two trips, first trip, then the first reclose after 29.984 seconds, and then the second trip and the circuit breaker locked out. Okay, so here is the end of our video. Thank you.